other set of tests that are carried out for your aerosol product are physicochemical characteristics of your product. Okay, in physicochemical characteristics, what all you check is you check the vapor pressure, you check the density, the moisture content, you carry out the identification of the propellant that are present inside the container, and you also find concentrate, that is the product concentrate, and concentration ratio is 80:10. In some cases it is 80:10. You have 10% or 20% of your product concentrate, and you near about 80. So that ratio is been maintained or not inside your container, that you check with your concentrate propellant ratio. Now let us see each test in detail. Now the first test that you carry out is the vapor pressure test. The vapor pressure is measured with the help of the pressure gauge. What is the importance of it? Now if the vapor pressure varies from container to container, so you are checking the containers, and if the vapor pressure varies from container to container, then you can say that there is some presence of air at the headspace. So you have a container over here, right? And if the container, this container is having some vapor pressure then different than this container, okay, then you can say, and the vapor pressure of this is high, the vapor pressure of this is low, then you can say at the headspace, at the top, there is some air that is getting present over here. Okay, that you can decide from the vapor pressure, which is measured with the help of pressure gauge. The second thing that you the second physicochemical test that you carry out is determining the density. Now density is usually determined with the use of hydrometer or picometer. Okay, now hydrometer, I don't think so you would be aware of what hydrometer is. Okay, usually the tests that are used to determine the density of a non-aerosol product, those tests are little bit modified. Okay, so those tests for use for non-aerosol products, for your liquids, for any of your suspensions, etc., whatever tests have been used, those tests are little bit modified, okay, in order to accommodate your liquefied gas preparation. So what you do is you take the liquefied gas, you liquefy your gas, okay, you liquefy aerosol, and you put this into this tube. Okay, so this is the tube in which you put it. You put it halfway so that you can so this hydrometer can go inside it, right? This is the hydrometer which is calibrated. So these are the calibration on the hydrometer, right? So this hydrometer is then placed. So you take this tube, okay, or you can say it is what you call that. Okay, so you take this tube, and inside this tube what you put is you put your liquefied gas or propellant. If you are testing it for propellant, then propellant, you put it inside it. Then what you put is you put your hydrometer, and you see to it that you rotate it for a few times. Okay, so rotation of this hydrometer is done till the hydrometer is suspended in this liquid. As soon as this hydrometer is suspended in this liquid, you find out the level of the liquid, right? And this level you coincide with the hydrometer your calibration. So this point, okay, this point is going to give you the density of your product. Okay, so what you do is you introduce your liquid under pressure, so that it is going to be in the liquid state. So you uh, uh, introduce your liquid under pressure through the hook wall. So this is the type of hook wall. Hook wall is nothing but the wall which is having both the ends open. Okay, so you introduce through the hook wall into the tube, okay, in which the hydrometer is placed, and the density is being read through it. So this is how you this is how you determine the density with the help of the hydrometer. Okay, next test that you carry out is the moisture content. Now the method that are used to determine the moisture content are Karl-Fischer method, or you can use the gas chromatography method. Now you very well know the Karl-Fischer method, you have already done. I'll just revise it with you. In Karl-Fischer method is based on what? It is based on iodine iodide reaction, isn't it? What happens is the brown iodine, when it comes in contact with water, which is present inside your material, the sample which you are testing. In this case, it is going to be the propellant, or in this case, it is going to be the aerosol. So it comes in context. So if there is some water that is present inside the propellant or inside the aerosol, then this brown iodide is going to get converted into colorless iodide, okay, which is in the reduced form. So then what you are going to do is, then you are going to carry out the titration. And in the titration, what is going to happen? This water is going to be consumed. As this water is getting consumed, so this colorless iodine, this colorless iodide now gets converted into, slowly and steadily, into yellow color, and then into the brown color. Okay, the brown color signifies the presence of iodine. Okay, it means the water has been consumed. The water that is consumed is been noted. So that much quantity of water was present inside your product, right? The second method that is used is the gas chromatography method, by which you determine the moisture content. Then you carry out the identification of propellant. It is in order to detect whether the propellant that you have put, it is of right quality. Okay. Then the method by which is the method that I use to determine the identify the propellant are gas chromatography and infrared spectrophotometry. Okay, so these are the methods that I use for identification of propellant. Next you carry out is your identification of propellant concentrate ratio, product concentrate ratio. Again, the method that is used is gas chromatography. This gas chromatography method, I think so you are having in third year in analysis. Okay, or if not, then you will be studying it in the final year. So this gas chromatography method is used in order to determine the product concentrate propellant ratio. So these are some of the physicochemical tests that are carried out for your aerosol